So Dr. Roshanghias will be, he's from Silicon, Austria, and he'll be telling us about advancements in hybrid flexible electronics towards ultrafine pitch chip bonding. So if you could share your screen. And good luck.
Yes. So hello, everybody. So here we will wanted to talk about a little bit hybrid electronics. It would be more technical compared to other talks, but this is like what's the portfolio we are working with it and offering in Silicon Austria Lab. Maybe you don't know Silicon Austria Lab, so shortly about this research institute located in Austria. So SAL, or Silicon Austria Labs, has 3 locations in Villach, Graz, and Linz, and working in different fields of electronic-based system, sensor, RF, power, integration technologies, and embedding systems. Within the sensor system, so we have a group, and my group is working on hybrid integration and packaging. So here we are offering in our lab, this is heterogeneous integration lab, together with our clean room facilities for lithography and printing. The solutions, different solutions that we will show later for different kind of integration on flexible, stretchables, and wearable electronics with different aspects from wafer to bare die and assembly components. We are also part of a roll-to-roll pilot line in Austria, working on paper-based electronics, and some examples is also from this pilot line. So shortly, one introduction. I mean, you know, all flexible hybrid electronics is still required nowadays because the fabrication of printed electronics alone is not sufficient for high performance application. Still, the silicon-based technologies are required, and how to combine the semiconductor electronics to low-cost printed electronics on paper, PET, and other substrates. It could be of challenge, but it's also the field, interesting field for researchers in with that applications in different fields. So generally, there are a lot of ways how you can integrate electronics onto the printed or flexible electronics. So this is all here, the full spectrum from permanent joints to the detachable. Probably all of us worked with some of this in some our daily usage, but what we aim here to target among all these possibilities in this talk is fine pitch integration that will be translated into 3 topics. First would be solder technologies, the other one with different adhesives, and then the thermocompression or thermosonic bonding. So we will just discuss in this talk these 3 aspects. But the question would be, why fine pitch? This wouldn't be applied to the common, or let's say conventional RFID tags with 2 terminals that usually the silver adhesives, this isotropic conductive adhesives would be sufficient. But rather we would just think about more advanced scenarios when you have a SoC, a system on chip, with different functionalities like a multi-sensorial chip plus energy harvesting, Bluetooth, or any kind of NFC communication, memory security. And when this all comes in one chip, then you will just, and you aim for miniaturization beside the high performance computing, then all the pitch sizes and number of IOs are increasing and the pitch decreasing. That means that you cannot work in a conventional way with the normal silver-based adhesives. And a lot of challenges here that comes up, the reliability of interconnects, bonding 2 materials from 2 different walls. One is the rigid silicon with resolutions from lithography, and another one would be a low-cost substrate with completely different mechanical and thermal properties, and how to bond it and merge this together would be the challenges that would be seen. Before going